Welcome to a new session of the Hitchhiker's Guide to the Glamorous World. And today I'm joined here by Jarret Atkinson. Hi, Jarret.
Hey, I'm a closure developer working at a small shop, and uh, Glamorous Toolkit is basically what I've been looking for the past 4 to 5 years.
Okay, so I'm glad you found it. Okay, so
Absolutely.
let's dive into it uh, and see what exactly do you see at Glamorous Toolkit. So what is Glamorous Toolkit for you?
For me, it's the way I want to do programming for the future. I love the concept of examples instead of TDE. I'm trying to actually do that in my current projects, even without Glamorous Toolkit. Um, but also the different ways of examining all of your data structures uh, is something I've been wanting to do for a very long time. I can do that just a little bit with some of the more specialized data structures that I end up with in my projects, but it's too expensive. And Glamorous Toolkit is interesting to me because it brings down that cost so low.
You mean the cost of, for example, views or so
Mhm.
for
I have
creating
a
these
lot of
custom
graphs.
views?
I have a lot of graph data structures, and it turns out to be really useful to visualize them that way when you're debugging them. But it's really expensive currently for me to make those. So I've only made it for a couple of the more commonly used structures.
Do you find yourself, yeah, so this idea of building it for the commonly used structures, is that due to like the idea of saving the costs or amortizing the cost for the things that are being more used? Is this where it comes from?
Mhm. It's a cost benefit. If I'm not using it very often, the 2 to 3 hours to create a visualization for it isn't worth it. But I have a couple that I'll be debugging maybe once a week. It's very much worth it to spend the 2 or 3 hours to speed up that debugging process.
Right. And so if you're finding that if we bring those costs down to minutes, then all of a sudden things change. And
Absolutely.
that's very interesting. Yeah, that was our assumption at the beginning. We didn't know if it would pay off or not, but it looks like it does.
Mhm.
So that's interesting. That's an interesting perspective. So you would see, for example, using Glamorous Toolkit for working with closure.
Mhm. Absolutely. So actually, there's a couple different questions with Glamorous Toolkit and Smalltalk, I suppose, and more generally. So if I'm making a tool that supports closure really well within Glamorous Toolkit, what's the distribution model? I've been slightly confused because it seems like you build up the editor as you code in it, but that seems to make it hard to share as well. You don't really know where the lines are of what modifications you've made, um, if that makes sense.
So let's see. You're saying how you will share the once you create an environment, a custom environment for closure, for
Mhm,
example, how will you share it, right? So when you're opening this here, this is
mhm,
Glamorous Toolkit, and you might want to open a different window, for example, as a default. That's one, right? But then you also had another dimension in your answer or in your question, which was about the editor, and I didn't really understand that one. But we can come
I'm
back
just
to
kind
this.
of
So let me just answer the first one. So how do we address the problem of building a new world, right? So it's interesting. Like if you go into the blog post here, we got this question recently, and so here on the right hand side there is a this blog feed, right? And that when you open Glamorous Toolkit the first time, you get asked, "Do you want to see our feed?" And there, if you're saying I want to get more posts, you get this list. And so here there's one article which is about how to create a standalone app with Glamorous Toolkit. And here this one essentially says, well, it's creating an app is as simple as writing a script like this. So if we run it, I'll get a new window. And the window will appear as the one below. It doesn't show because I'm only sharing one window right now on Zoom. Um, but it would be, if you run this, you will get this picture that you see here at the bottom. and that will be another window. And then if you go further with the instructions, there is a way to, for example, just simply close the current G2 world, and that's it. That's all there is to it. So,
Okay.
so let's see if I go here and I say, I'm just gonna take this code and I will open a playground just so that we can play with it a little better. Um, so here I have a container, and in the container I create a label, um, and then I want to create a space. So if I inspect that, I should see that I get that space over here. And if I open it, right, so the children of that space, so you have everything that you put inside. It's just a scene, normal scene made out of many just elements, and that's it. and then if you close the default GT world window, then you get your application. It's that simple.
Gotcha. So how would you go about distributing this? So say me and a team member are both using Glamorous Toolkit. Both of us make a modification that adds a new visualization to each of our workspaces. How do we end up sharing that back to each other?
Great. So the Glamorous Toolkit here is actually made out of many little projects. And some of them are due to, just a second, I'll show you another example. But basically it's already made out of many sub-projects, Glamorous Toolkit.
Mhm.
And as a consequence, we also have the same problem. So when we are creating something, we want to be able to show it to our colleagues. So the question there is, how do we do that? And all code actually goes into Git, and from Git, we construct the whole image again. So you can think of it being kind of similar to how would you go about sharing a Docker installation. So how would you do that, right? So you commit your code, and then there is a process that constructs another distribution. That's the simplest way. So I'm going to share now another scenario here. So here you're seeing main documentation of Glamorous Toolkit, and there you see how these are the projects that make Glamorous Toolkit. These projects are actually added or loaded on every single commit. Every time we commit, there is a continuous deployment scenario that basically tests everything, builds the whole image again, tests it from scratch, and then deploys it. That's what you download when you go on glamouroustoolkit.com. There's also we also already also have the support for creating releases. So if we go to so basically here we see all the different components. So here next to these components, you will have your own components that will be specific, for example, on the one hand, maybe for closure, but on the other hand, maybe for your specific project. Because even when people work with just vanilla, Glamorous Toolkit plus, but apply them on maybe on their system, and maybe their system is already implemented maybe in Faro, or maybe we just have a domain of it implemented, so the specification of it implemented in Faro as a language. Then we would have modules that are specific for the project, and those are separate. And so you get the Glamorous Toolkit modules, and on top of it, you'll have your own specific module. So the way you release your executable, your environment, is basically the same as how we are releasing Glamorous Toolkit. And you can also utilize the tools that already exist for that purpose. If that makes sense. Does it make sense?
It pretty much makes sense, but correct me if I'm wrong, this seems to exclude, or at least make it a little bit you have to take a different path if you want to go and make plugins. So if you want to have like three different people who've all made their individual modifications to Clojure support, can you load all those at the same time and release that?
Of course.
Or
Of
okay.
course. I mean, that's the whole point. So here, for example, you're seeing this. We already have a full support for going from a single, because here we're gonna have maybe, let's see how many there are, 88 different components. So 88 different uh, actual modules that are in, I don't know, not quite as many GitHub repositories. And so one issue is that we want to have full traceability, which means that anytime we commit anywhere in this space, we want to be able to release a whole Glamorous toolkit, but know exactly what has been committed. And we're doing this without any branches. So we're committing directly on on master, and then there is a process that goes and picks and figures out what were the commits, and creates diffs that we put, for example, in release notes automatically, and produces the executable. So this is available out of the box, and it's called Releaser. And you see here, this is the description for how you go about doing this, and it knows how to go into GitHub repositories and find out what what were the changes that were happening there, and only release the necessary projects, not everything, and update the whole map, and then release on a separate branch. That we call it the release branch.
Gotcha.
And so that's basically the process. And so the way you would share, it's like you would share any other piece of code, which is you would put it on some versioning system, and then you would work with multiple people there.
Okay. So and if I make a change to my configuration, like adding one of those Clojure packages or not, for Java package or whatever, I would change the configuration of releaser to include that package, and then rerun the release build, and then I get a new instance of Pharaoh with that plugin included.
Yes, exactly, something like this. But basically, what you will see, so here is what is this kind of, what do we see when we get there? This is called baseline of Glamorous toolkit, and baseline is the way we are defining dependencies. So it's like the npm thing, or Maven in Java. So how you would define dependencies there, and so how these, like, so this is normal. It just looks like a normal class. It's the engine behind is called Metacello and comes with Faro. And so here you're seeing the baseline method, and basically this is just a Fluent API. And then here it says, well, spec baseline, which means that this Glamorous toolkit depends on Glamorous toolkit clipboard. So if I will go here on the visualization map, then this GT clipboard is here, right? It's a GT depends on GT clipboard. You can see it here, and then this basically comes from these dependencies that I just described here, which means that if you would now ship your own environment, you would have a baseline of your environment that will depend on Glamorous toolkit and on your packages, and that's what you would add on top of, and this is what you would load.
Okay.
There. And maybe just to show here, so this is, now we are in Coder. This is the Coder, is the tool with which we're writing code. And what you're seeing here, this is this triangle that we usually have for expanding messages that we have, so just to show the method. But here we're expanding it for the string, right? So here I see a dependency to the Glamorous toolkit clipboard. And it can, if I expand that one, actually expands the baseline method of the baseline of gtoolkit clipboard class. So there's actually a plugin that kicked in here, and that recognized the API. And because it recognized the API, it expanded the actual method in place. So it's just to make it easier to construct these types of dependencies, right? So you even have here, for example, completion inside the string in this case.
That's really slick. I like that. So this is almost like your Maven document whenever you're working in a Java system.
Precisely, that's what it would be.
Okay. Okay, that makes it pretty simple to get through. So I guess actually you introduced the question while you're going through that. Do you see what's in G Toolkit right now as being primarily a small talk environment with a lot of uh, what do you call them? Uh, Preloaded packages that are designed to allow you to explore other systems like Java, JavaScript, but mostly oriented around Pharo? Or is it pretty simple to bring like Coder up to date with being able to do Pharo or Clojure or Java inline?
Well, so Glamorous Circuit, the aim with it is to reinvent the development experience, and we start from Pharo because that's what we use to build Glamorous Toolkit. But
Mhm.
the target of Glamorous Toolkit is any other language. So Glamorous Toolkit is a platform for constructing system-specific IDEs, which also, of course, then includes language-specific IDEs. But we want to go a step further um, and say, well, if you have your system should be special. Now, it's interesting because if you look at your system, it's probably not just Clojure, and it's probably not just Java, but there is something also around it, maybe a
Yeah.
framework, maybe
Oh, good. What is that?
some XMLs and some JSONs. And
Look at stickers. There you go.
I hear something on the line. Right. So, and the projects based. So when we would create this, system specific environment, you want to take into account what the system is. You can't assume the system is this, because you just don't know what that is. You don't know what that system is going to be. And if you do not understand the specifics, let's say, for example, you have a Java system, and but it's not, but it's actually implemented using Spring. Um, if your tools do not take into account the meaning of the Spring annotations, uh, all that Java support is not particularly useful, because what matters is actually there's a lot of knowledge that goes into exactly those annotations and how they are, put together. So that's where the variation is, and that's what we need to support. So that's the intent of Glamorous Toolkit. Today, it is a full environment for Pharo, indeed, but it's also a full environment for the language with which we define support for the other languages, right? So when we go to something like JavaScript parser that I like to show, right, this is another language. This is not Pharo. Um, and this is the language with which we define the grammar um, for the other languages. And all the environment is already made, or it is made, or is built on top of the SMAC, of the parsing framework.
Okay, I think I understand that. So the core part of the question was, would I make the coder in the playground support Clojure, or would I preferably make Glamorous Toolkit spin up a new window, close the old window, and then do whatever I want in that new window?
Well, so you definitely want to start from an editor. Like, for example, here, because we are embedding it directly. So this, for example, this is a language. By the language, it looks like this. If I would open it on a separate file, it would be like that. But it already, in this case, we already have a mapping to the classes, to Smalltalk classes, so to Pharo classes. Then, so from there, actually, this one is stored in the comment of the file, or in a, yeah, in the class method that stores that's stored somewhere here. So this definition comment, that's what will have the actual code of the parser. And then from there, the rest of these methods are actually generated. And it's just a lot of, code that we never read because we always just gonna read this. Now from here, we said, well, if we have this, we actually don't want to see it as a text. We'd rather see it like this. And so now what you're seeing here is this is an editor that just so happens to be presented next to the class. But it's an editor that is about the instance of the parser or of this specific parser. That the fact that the parser is mapped on the Smalltalk class simply just allowed us to insert it here in the coder experience. Now, in your case, right, because there is no mapping to Faro or anything like that, which means that there you want to have that editor. This editor is the for and front. This is what you want to build. And then on top of that, then you will see what kind of navigations you will want from it. Now, playground. The playground is already an interesting space because every playground, even now, is here. If you say, I want a new one, a new snippet, there are different kinds, there are different types of snippets, which means it doesn't have to be, they don't have to be Faro. You can have your own language there in the playground. So this is like a projection editor for for writing these kinds of scripts.
Okay, that's cool. So, okay, that basically answers that question. And that also actually answers the second question I had.
Which is
so
which one?
It was about, I'm gonna have to go look at it again to remember. It was about project management. How do I switch code bases? But that's kind of implicit if I'm building tools already in Glamorous Toolkit to make it happen.
Right.
Like if I have, the fourth question was, if I have like 5 different code bases and I want to switch between them, how do I indicate to Glamorous Toolkit what's going on? But if I'm already making, for instance, a Smalltalk closure project instance, I can make, actually, I'm just kind of curious, would I be able to make that searchable? And then
Why
whenever
not?
I load that,
Of course.
oh, right, okay. That would
And
actually
so,
be a lot easier.
yeah, so in the search would be handled through Spotter here, or Spotter instance. So which, and Spotter is also moldable, which means that you can, if once you have your model that you have, or that knows how to, or what it wants to search, then you can plug it here and the interface already exists. And then you can take this interface and plug it anywhere else you want. Notice how even in this generic, or in the stock Glamorous toolkit, there's almost no global, there are no global actions. There are only global entry points, but there are no global actions. And that's by design like that. It doesn't start with, there are definitely no global menus. No, so everything is context specific. So context is first, it's an object-oriented interface. You start from the nouns and then you add the verbs to it, right? Rather than the other way around, the verb noun decomposition. And because of that, then it's easy to make it be what you want it to be, because the frame doesn't assume pretty much anything. So so here, for example, if I'm in Coder, maybe let's take this one. Here there is also a search button, but this search button is different than that search button, although the engine is exactly the same. So here I will be searching for the things that are starting from this class. So I can search for the instance method, I can search from the class methods. And so it's specific here to this context, but it's the same engine. So you can, once you have the engine available, then you can do what you want with it. So maybe let me show this one. So if I say here, I have an address book example. the address book example, and let's take a look at the map here. So here I have a map. Well, I have an address book with 5 um, contacts. So completely has nothing to do with programming, just a domain, right? But then here in the, because this one knows how to search itself, already the inspector gives me a generic search button here that if I click on, I will be searching through people and addresses and phones. And if I go to any of these, then in there now, I'm in an address, and in the address, I can go and see the people that are related to that address. So now you can apply these. This is like an operator, and once you have a target domain, then you simply apply the operator to your domain, and that's it.
Mm.
So when you will be having your closure um, closure specific environment, you will have entities that are specific to modeling closure constructs, and those are now the target of being searchable. Those will be implemented in Faro, and that's what you will want to search through.
Okay, that sounds doable. This is all turning out to be a little bit easier than I expected, which is very happy surprise, I will say. So from the I forget what it's called, for the Glamorous Toolkit rendering engine, is it possible to
Block.
add? Sorry.
From block.
Gotcha. From block, is it possible to embed stuff like a Chrome instance for visual debugging? Like if I'm generating some HTML out of a block of code, is it possible to embed stuff like Chrome or I can't think of any other examples right now, but is that possible?
Is it technically possible? Yes, it is possible. Do we ship with such an integration? No, not yet.
Okay.
But is it possible? Yes, it is possible. Yes. You can embed any arbitrary external surface anywhere in this scene that already exists. We already have support for it, and we already have demos that show that this type of things work. So if you have any other external module, could be maybe C or something like that, that produces something that you want to embed live anywhere in this scene, this is possible, and it's not a lot of, it is work, but it's not a lot of work.
Okay. That sounds excellent. So what else? And that wouldn't screw up the one rendering tree at all?
What is with the one rendering tree? No, that's exactly, oh, I see. Would this not interfere with the one rendering tree? It would not interfere because we have this notion of compositing. So the idea there is that you have, I'll just show a picture. Let me share the screen. So here you're seeing layered. This is actually a window, and you're seeing the layers that are actually being used to produce the final rendering. And this is called compositing. So these are render layers, and each of these can actually be produced on the one hand, can be delegated to any CPU or GPU, but it can also, it can be contributed to by something else. So it can be simply like another module that will, some external logic that would produce these views. For example, if you would want a video, it would make little it would be not particularly useful to have it be go through the Faro image, because that's not really a good use of Faro for. But you could directly do it directly from a C player, and you would embed it here, something. So that would be, that is there's already support for that. Would you still have a one rendering tree if you would go there? So by one rendering tree, we mean that everything in a scene is simply an element. So there's just one DOM. You would go back to having the same problems that you would have in HTML when you embed a Flash video, or um, to some extent when you embed a canvas, that you don't know what's inside. When you're at an HTML level, you don't know what's inside the canvas.
Okay, that makes sense. You just at some level introducing the problems you're trying to avoid, but it is possible.
It is possible, right? So for some things, right, you will want to be pragmatic and use what things exist, because it's not reasonable to think that everything is implementable here. Everything is implementable here. Is it timely implementable? That's the question. So, but for the reason we have this one rendering tree idea is because we wanted to have these live editors, for example, the ability to visualize things, combine text with visualizations anywhere in the scene, without being constrained at that level. So the core development experience. That's why we have worked on the one rendering tree, but um, that does not, it should not prevent somebody from being pragmatic.
So, very different subject. Could you tell me a little bit about uh, the what's it called, visualization engine that you've included in Smalltalk? It appears to be quite a bit more extensive than what I'm used to with stuff like Vega and whatever's shipped with Linux.
Okay, so the Glamorous Toolkit is the graphical stack of Glamorous Toolkit is already a visualization engine. So there's no difference between the widget stack or the visualization engine. They are the same. So here, for example, we have this. That's what we mean by one rendering tree. So, for example, here in this scene, we have an editor, and we have a keyboard over here, and we have a chart, and they are all part of the same tree. Like everything that we see in this window is rendered by the same tree, including this chart. So there's no difference there. And that's why we can go, so if we, like here, we're having a tree, right? And then in the tree, we have like widgets, complicated widgets inside the tree. So what this one shows here is that the widgets, any widget can be part of a graph layout, for example. So there's no, because the graph layout is actually not a special layout. It's just another layout. That's one interesting part in this stack. So that's the path that we took for the visualizations. Now on top of that, of course, you want to have simple to use APIs. So you mentioned Vega. What's interesting about Vega is that it has this declarative API that you can serialize nicely. You can manipulate it in all sorts of interesting ways because it is declarative. So it's based on that idea of a grammar of visualizations. And that is a layer on top of what the rendering part can do. So we're quite there. That's where our next focus is going to be at. But there's already some of it available. For example, if we go to there are some Mondrian basic examples. So Mondrian is one of these engines. Mondrian was a painter that saw the world in terms of boxes and lines. So that's where the name comes from. And so here you're seeing just graphs, and this is a tutorial for how you're going to build various kinds of representations with with a simple API that you can just directly play with. This is a graph representation, but there are other kinds of things like plots and so on. And those are simply just other builders, other kinds of little DSLs, essentially, through which you will construct or define those builders. But then at the end, the interesting thing is what happens once all of these are, you put them together and you construct these interfaces. So here, this is an example. You were mentioning that you like this idea of examples, which are like tests that at the end they return an object. So this is an example, and instead of here this triangle that expands things in place, we have these dots that it can expand things on the right. It's just a different application, basically. And so here, if I do that, then all of a sudden I have two. So I kind of have here like a tree, like it's a graph, but then I'm laying out the elements inside. But what's interesting is what happens when this one starts to scroll. Because here, right, the lines go with the scroll. And this is only possible, or easily possible, if this dot and the text and the line and this pane belong in the same scene. And once they belong in the same scene, and you can then you can seamlessly create these kinds of interfaces that are otherwise hard or close to impossible to create, right? And this is not expensive to do, right? So let's build this maybe completely, maybe enlarge this one. And so what you see here, I have, okay, 4 different things, and then there's some dot here. And if I expand that, I can see, okay, they're actually using the same, they're relying on the same method at the end. So this is an interesting thing, but then we can go a step further because these are examples, and because of their executable, and because they return an object, and I can start to visualize them with my inspectors, right? So then you can get these kinds of interesting effects. Well, not effects. It's just it's a tool to understand how this large thing was composed out of the smallest things. So the question is, how would you call this tool? You know, what is that? Is that a visualization? It's definitely not what you see when you look at typical visualization, even in the JavaScript world. You don't expect to have full editors inside the visualization, and definitely not things like you know, like here with syntax highlighting to be live, and these dots are actually added by the syntax highlighting tool. Those things are, you don't consider them, like we think of visualization to be usually a completely new, different world, and that's kind of limiting. And so what we are having here as an infrastructure is you can create much richer interfaces that have not really been explored so far. Does this address the question?
Pretty much. Yeah, I think so. The only question after that, I suppose, would be all these visualizations are built in Pharaoh. Is there any technical limitation to putting a facade of something like Vega, where you can declare it into the language and send it over the wire to GT?
No, exactly. That's what I said. That's what I said. So there is a, if you go back to the Mondrian part, this is let's just take an example here. Here you're saying I want some nodes, and it just lays them all like this, and then I want to have some edges, and then I'll have them shown here, and then I want to see it, I want to define the layout, and then I'll see it like that, right? So can this be can this specification be defined in some other language that we can interpret over here and then produce the scene? Of course, there's no limitation here. So on top of the this little Fluent API called Mondrian is a really small implementation. It has a few hundred lines of code on top of the that comes on top of the normal graphical stack, and brings together with it brings the visualization. Now, Vega will be a little bit more sophisticated than that and would require more effort to build, but it is just a matter of implementing it. And we are already probably like our infrastructure is more expressive than you could express with JavaScript. Um, but at least, but it's given that if you take something that targets JavaScript as a means to render or to transform and produce the final graphics, we can definitely handle the same things.
Okay, that makes a lot of sense. Is there any particular place that you would start looking around to implement additional languages? I'm working on the SMAC compiler in my spare time, but is there anything additional that I should be looking at that would be useful in early stages?
No, that you should be looking at SMAC and getting you start from the grammar, and with on top of the grammar, you can build the editor, and then you can build the completion. Completion will probably take a look at the syntax tree, take that one into account. Once you have the editor, you do want to work with the runtime of Clojure, because you don't just want to edit, you want to run, and then you want to debug. So that is another part. We already have a technology which is called FireLink that allows us to connect to other runtimes. So in that case is Faro, but there's already one for JavaScript, for example, JSLink. And a similar one can be built for other languages like that. So that's what you would look for.
Wonderful, wonderful. I'll start looking at that.
So this is the baseline for FireLink. That's what you need to look at.
Okay, I'll do that. And I guess maybe the last question I have is how could you show me your SMAC workflow? Because I've tried it 15 different ways and all of them seem kind of kludgy and maybe not like I would expect it to behave. I would kind of expect I'm probably missing something, and there's an easier way to do it than I've been doing it.
Right, so when you're starting, you're going to start with just saying here SMAC. So I have some parser, some scanner. I'm going to say where my some parser. And then have that. Okay, if I create it, then it gives me that. And then if I say here something, then it will just give me a plus sign to create it. And I'll have it here. And I can just say here, what? And so this is how we create the grammar, basically. So here's how you created something for the scanner. So that's the current intended way. Does this address the question? And then of course, yeah, for every time you have something that you want to test, then you press on this button, then you're gonna test it. You can test it locally like that. You can also write the same kinds of, you can write tests also using the simulator.
Okay. I guess my hangup is probably just that it's so different than what I'm used to working with. So I'm trying to get my head around working with it easily.
So this is actually the first interface that we built. It came almost before the normal coder one. Um, and so we should go and update it. But yeah, so just
No, 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 no.
to make
It
it a
works
little
great.
bit of course,
It's
no,
just
I'm not, of
very
course it
different.
works, but it's a little bit different than what you would expect when you're editing, small talk methods and so,
Mhm.
or small talk classes. And so we would want to unify the two fields basically so that we don't have to think too much.
Gotcha. Okay, that sounds great. Um, I guess all the other questions I have are extremely specific, so I'll
Go ahead.
put those in the Discord at some point.
Okay.
No, it's not something I can get over
Right.
verbiage.
Okay, cool. So one other thing I just wanted to show you here, this one, this is actually a snippet which is called Jenkins. And if you have APIs, if you have a Jenkins, so here, this is our Jenkins, and this is a private Jenkins. So if we go there, then you're gonna find all sorts of things in there, and there you're having we're browsing now the API, the remote Jenkins. So when people think about building a system-specific environment, we kind of most of the time think about, oh, this is the source code. But very often our systems are made out of also um, dependencies to other systems, right? Maybe to APIs, or maybe our system is already deployed as an API, and we would like to go and see what that one is. Or maybe I have an API that I need to integrate with, and so I need to go and browse what that one is. So what you're seeing here, this is actually one of the. So this is actually a development environment or an environment for browsing Jenkins inside Glamorous Toolkit. And in our case, when we are having, for example, failures, um, we can, I don't know, let's see what that one is. We can browse to that one, but so here you're seeing system specific highlighting of the console, basically, right? Of what I see in Jenkins. So I don't want to go and read lots of lines unnecessarily. Um, so it's just an example of what you can do with it. Right?
Mhm.
Then you can
Absolutely.
see where the error is. So once we have learned, oh, this is an error, then next time I don't want to search for the same error. I don't want to spend the same time finding what is the error, right? So once you learn it once, we don't add it to Stack Overflow. We build a little tool that documents it in place. And that's how we gain knowledge. And that's how this is where we can optimize. And so that's also the risk, because like people will say, okay, but you already have a Jenkins interface. Why build another one? You build another one exactly because of this, because this is moldable first, and you can create custom-made views for it.
Mhm.
So here you're having a Jenk or an editor that takes, this is syntax highlighting that you're seeing here. Only the syntax highlighting is actually just based on pattern matching. Well, it's not, it's more. So if I go here now, if I look at how this is implemented, it says here that there's a styler uh, for the for the console. And if I browse that styler, I'll see that it's actually um, it's a grammar. And there's a parser that I'm defining here. This is a different parser, which is this is not SMAC. It's called Petit Parser. And so Glamorous Toolkit ships with two kinds of parsing frameworks. SMAC is more like a classical parsing framework, top down, and Petit Parser is a peg parser, basically. So here we're constructing one of those. It's lighter weight, and you don't need to have a full specification of a language just to use it. And we're building a parser on the fly here. So here, for example, it says if it's start of line and something, then I want to, in this case, add this color to it. And sometimes we're adding an expander. So if I'm referring to a method inside the console, then I want to go and see the method right there. I don't want to copy anything and paste somewhere else, kinds of things. So, and this is it. And basically, whenever we learn about a new kind of an error or problem that appears, we simply add it here, and that's it.
That's great. I didn't realize you could do partial parses. This might be helpful for some of the more boutique stuff that you work with.
So here it's here you're seeing exactly this. Maybe let's do one. So I'll just copy this piece of text. I'll just start another one. So let's say if I have here a string, and the string has something here, and then some pattern like this, and something else, and then maybe again some pattern, similar thing, and yet something else. All right, so this is a string, and let's say that we only care about these parts over here. So we want to build a parser for that. So I'll say here, okay, basically what I really care about is just this, or maybe even this, and anything that happens, anything that is not. So this is as parser. Then this one is parser negated. Negate. Then I have a star here, and then I follow it by closing this. So let's quickly check this one. If I say p parse this, let's see if it works. It does, right? So it parses the first ones, the last one, and a collection in between. Let's make it flatten here. And so now I have exactly just that, just the string. So, okay, and so now let's say I want it to parse my original string. Of course, if I do that, it won't work because it expects this, but it doesn't find it as the first character. So what I can say here, instead of just the P here, I will say I have an operator which is called C. This comes from something called bounded C parsing. So bounded C parsing says, well, you're looking at the whole thing as a whole text as being an ocean. And what you care about when you're navigating the ocean, you're caring about the islands. So the P is the island and everything else is a sea. So if I do now this and I parse, I will get everything that comes before the first AABB, and then everything comes afterwards, right? So let's see. But now, of course, I have two of these. And so I need to say, I want to have two of them. So now I'll have two collections. But before we do that, so let's hear, right? We don't care about what comes before and what comes after. So we just care about the second one. So if I do this and I say second, I'll just get the AABB, my original parser. But let's say that, for example, here, I only care about the second also because I don't care about the beginning and the end. So if I execute that one now, I'll just get my string, AABB. And if I now do this star, and so I do this whole thing multiple times over my original string, I should get AABB multiple times. And if I add here, for example, like that, then I'll see AABB, AACC. So this is an example. It's very nice framework to build quickly. You can build sophisticated parsers that are not complete. It's very interesting for casual kinds of parsing, for example, for log files or for some text that comes in and you still want to discover what's it about.
Is it possible to run these parsers, which are they're really, really nice to run over these trees, or excuse me, these strings? Is it possible to run them on trees as well? Potentially get information out of them?
To run parsers on so parsers you run them on streams, so on collections, not on trees,
Mhm.
but they produce
Okay.
trees.
Right. Okay. So how do you go about implementing the Spring annotations in Java systems?
How would we go about or so there's already we already have the if we would have a Java class, then we have a Java parser for it, and this Java parser already knows how to um, somewhere there's annotation here, right? So it knows how to um, handle, or you will get an absent syntax tree node for the annotation, and then you will do something with it. Is that the question?
Mhm. Not quite. So if I have a well parsed smack tree um, of some file, and I'm looking for some pattern in it. Maybe the pattern is I have an if statement, and right before it is a int x equals whatever. Is there any way to describe that
Ah,
with the parser,
okay.
or does that even make sense to do?
Yeah, okay. You mean you want to do pattern matching over an absent syntax tree?
Yep, pretty much.
Yeah, okay. So there is, in fact, an extensive um, whole search and transformation engine that works even across languages. So SMAC comes with that. So all this part here with the rewrite uh, is done like that. So let's see if we can find something. I don't know if I have an example here ready, but so if I have here GTSD matches, look at these examples. So here, for example, we're looking at in a Java in an absent syntax tree um, of Smalltalk, and here it says, well, some receiver, let's say call A, and then followed by and then some collection of variables. This is a collection of variables. This is a collection of temporaries, and then some statements. If this is what we're looking for here, and so for, or here we're having an even more complicated kind of. So you can build this kind of linked rules, and it's a sophisticated pattern matching query language for specifically for absent syntax trees. So once you have your trees, your SMAC trees, you will get these kinds of searches out of the box. You don't have to do anything. You just can use them over
Okay,
your SMAC.
wonderful.
And you can define, all refactorings are also defined like that in Smalltalk and in for all other languages.
Wow. Okay. Well, that'll make life a lot easier in a lot of cases.
So here, right? So here you're seeing how you can um, rewrite parts of the of methods in this case. But yeah,
Wow. Well, that's all the questions I have. I've got a lot of ground to go cover now.
great. So thank you very much for your time. I'm glad to see all the energy, and I'm very much looking forward to seeing the output.
Absolutely. I'm as happy as you are that that GT is around. This is what I wanted for forever.
Great. Well, thanks a lot for your time, and see you in our community.